Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. Dear students, welcome back. This is our week number 13, and in week number 12, we were discussing our chapter number 7, which was about series parallel combination. And in that week, we discussed about identification of series parallel relationships. And in that discussion, we learned how to recognize how each resistor in a given circuit is related to other resistors. And we learned how to determine series and parallel relationship on a printed circuit board. And then I solved different examples to show about relationship between series and parallel uh, combination circuits. And in this week, I will focus on analysis part of series parallel resistive circuit. In the analysis of series parallel circuit, uh, it can be approached in many ways depending on what information you need and what circuit values you know. The example in this section uh, obviously do not represent exact voltage, but they give you an idea how to approach series parallel circuit analysis. After completing this section, you should be able to analyze series parallel circuits, determine total resistance, determine all the currents, determine all the voltage drops. And let me revise something. If you know Ohm's law, Kirchhoff's law, and the voltage divider formula that we learned in chapter 5, and current divider formula that we learned in chapter 6, and if you know how to apply these laws, you can solve most resistive circuits, and you can solve different resistive circuit analysis problems. And the ability of to recognize series and parallel combination is of course essential. A few circuit such as the unbalanced Wheatstone bridge do not have basic series and parallel combination. Other methods will be used for these, and inshallah, I will discuss later in this chapter. So let's start with today's topic, that is how to calculate total resistance. Do you remember in chapter number 5, you learned how to determine total series resistance? And in chapter 6, you learned how to determine total parallel resistance. To find the total resistance of series parallel combination, simply define the series and parallel relationships. Then perform the calculations that you have previously learned. Now, I will share few examples to illustrate this a general approach. And for this, I have to switch on the paper. Let's look on your slide. Now, as you can see, I have to change its presentation mode. Now, you can see the work area where we can uh, perform our calculations. So, okay, sorry. The first example I will show you here is R1, R2, and R3. This is the same start that I took in identification phase. Now I am putting some values with them as well. In identification phase, only the names were there. Now you can see we are playing with values as well. Now please tell me that uh, which part is in parallel and which is in series. R2 and R3 are in parallel, and R1 is in series with the parallel combination of R2 and R3. Okay, uh, if so, then we can apply a parallel formula for two resistances to solve this circuit. So R23 is equal to R2 times R3 over R2 plus R3. What is the value of R2? It is 100. And what is the value of R3? It is also 100. So 100 plus 100, their product over sum. It simply generated 10,000 and it is 200. Values will be, uh, it can be solved mathematically, that will result in 50 ohm. So the new circuit we have is R1, R23. It is of 10 ohm and it is of 50 ohm. So here RT total resistance will be R1 plus R23, and it will be equal to 10 plus 50. This is a simple problem. Now I will share with you a bit difficult example so we can have a better idea of it. R1, R2, R3, R4, R5, and R6. You can see here there are multiple small combination of series and parallel circuit. And here we can use a reference ground. This means that they are both are connected. So Vs of any value is connected here, and important part is their values are all of ohms. So to make it clear, I am writing ohm with them 75. Now you can see which resistance combination is in series without disturbing the connection. R2 and R3 can be solved in series, as well as R4 and R5 can be solved in parallel. So 47 plus 47 R2 3 is equal to 47 plus 47 equal to 94. And again R6 will remain same, 75. Here here R4 5 will be equal to, I can solve here, their product over their sum. 39 multiplied by 68 divided by 39 plus 68. We can use calculator here. I already opened it. 39 multiplied by 68. Value is 2652 over 39 plus 8 107. So 2652 divided by 107, it will be equal to 24.79 ohm. So here R45 is equal to 24.79 ohm. Approximate. So it is R1, it is R23, it is R6, R45. I think uh, this can be connected like this. And again, this is now R45 we can solve it as a one resistance. This is 24.79, or I can approximate it as 25. So R456 will be equal to R23 is 94 and R456 will be equal to 75 plus uh, 75 plus 24.79 will be equal to 99.79. So we have this form of reduced circuit, and here what I can do, R1 of 100. This is all because you are saying, sir, don't uh, rub the circuit or don't remove the circuit. I first step with this circuit, second step with this circuit, and then this circuit is formed in third step. Okay, we have left with a smaller edge, so I can draw here. Now these two resistance are in parallel. So 94 times 99.79 divided by 94 plus 99.79, that will be equal to, so again calculator for our help, 99.79 multiply by 99.794 point by the whole, this is equal to 380.26 divided by 94 plus 99.79, 193.79, and the result will be 380.2 by 3.9 will be equal to 48.40 ohm. Let's have a look here. This is our parallel combination of R23 and R456. Now what can I do? I can remove this first circuit to manage the space. So R26 R26 is how much value? 48.40, and supply is connected here. So This is 100 ohm and this is 48.40 ohm as we have calculated. Now RT will be equal to 100 as both are in series. 100 plus 48.40, so it will be equal to 148.40. Look, a circuit that was seemed to be quite difficult is now solved into a single resistance. I hope so. You will also be able to solve the circuit in the same manner, inshallah. Now, I am moving towards another important part, how to calculate total current. Now, we can improvise this circuit by uh, taking this voltage source as of 30 volt, and we have calculated total resistance. Then we can calculate total current. Let's have a look. If this is 30 volt, then we have total resistance. So IT will be equal to total voltage or source voltage Vs over RT, and Vs here is, I have assumed that it is of value 30 volt and RT is of 148.4 ohm. Then what will be the result? 30 divided by 148.4, 30 divided by 148.4, 0.202 ampere. Or what I can do, 1, 2, 3. It is of 202 milliampere. Now, uh, this was the easier thing that I discussed with the previous topic. Now, the important thing is how to calculate branch current. Using current divider formula or Kirchhoff current law, Ohm's law, or combination of both. What you can do, you can find the current in any branch of a series parallel circuit. In some cases, it may take repeated application of the formula to find a given current. The following two examples that I will solve will help you understand the procedure. Notice that subscript for current variable I match these R subscripts. For example, current through R1 is referred to as I1. So keeping in view this note, let's start with our example. Now we have to find current through R2. R1 here is 1 kilo ohm. Okay. And R2 here is 2.2 kilo ohm. And R3 here is 3.3 kilo ohm. So oh, I can show it like this one, and voltage applied is 20 volt. The question says find current through R2, and what is R2? R2 is not connected directly with this 20 volt. So what I have to do, I have to find equivalent resistance whole circuit. So for R2, I will be calculating first parallel combination of R2 3. 2.2 times 3.3 over 5.5. I'm doing it directly. Now you are comfortable with direct calculation. 2.2 multiplied by 3.3 will be equal to 7.26, and this 7.26 should be divided from by 5.5, and it will be resulted in 1.32 kilo ohm. Here, what can I do? Look at the figure. Now I have calculated parallel combination of these two. Now what can I do? I can uh, add this R1 to R23 to find its series combination. R23, R1. So 1K, and R23 is 1.32K. So IT, I can calculate total current. That will be BS 20 and divided by sum of both, because these are in series, and total current in series circuit depend upon the combined effect of the resistances. So to make it easier, I can simply find out RT 1 plus 1.32 equal to 2.32 kilo ohm RT. So 20, IT will be now equal to total voltage over total resistance. So IT will be equal to 2 point, sorry, 20 divided by 2.32, and it should be equal to 8.62. And as 2.23 is kilo, so kilo is in denominator, it will become milli at numerator, and voltage divided by ohm will result in ampere. So IT is 8.62 milliampere. Hooray! We have completed our question? No, not at all. We have just find out IT. Now I have to find I2, that is uh, our actual task. And what we can do? We can simply apply current divider formula here. I2 is equal to R3 over R2 plus R3 times IT, as we discussed in previous chapter. So I2 will be equal to, what is the value of R3? It is 3.3 over, their sum is, we have already found it, 5.5, and IT is 8.62. Now calculate this ratio, that will result in 8.62 multiplied by 3.3 divided by 5.5. The result will be your current, that is 5.17 milliampere. Now you have found out I2. I2 is equal to 5.17 milliampere. Similar problem you solved in chapter number 6, that current uh, is flowing uh, here, total current is flowing, that is here 8.62 milliampere, and one branch gets current of 5.17 milliampere. And how much current the second branch will get? Obviously we can find it by difference of both. So I3 will be equal to 8.62 minus 5.17, and this will be equal to 8.62 minus 5.17, and this is only possible if current is dividing in two paths, or it is possible for multiple paths as well, given that only one path current is unknown. So I3 is 3.45 milliampere. Hopefully you got the idea that how we can calculate the current in series parallel circuit, and in each branch how we can calculate the current. So bit complex problem is awaited uh, to get better idea of our concept. And what is that? I1 equal to 560 ohm. I1 we have the actual target is to determine current through R4, and Vs here is 50 volt. R1 is 560 ohm. R2 is 330 ohm, and R3 is again 330 ohm, and R4 is 560 ohm. So what we can do? So here we have circuit, and we have to current through this resistance R4. Now, if you look at the point, current, this voltage source is directly connected with this R1 and this whole combination. So, uh, we don't no need to discuss the current flowing in R1. We will directly jump on R2, the second group. So we need current through R4. For this, uh, we have to solve this parallel combination. R34 is equal to their product over their sum. 330, and it will be equal to 890. Just we will do a simple calculation. 330 multiplied by 560 and divided by 890. It will be resulted in 207.64 ohm. So R34 is equal to 207.64, and now I have R2 and combination of R34 in series, like as previous circuit is same, so I'm not drawing it again. 330 and 207, and the current through this circuit will depend upon the series combination. So I can say it is A and this is B. what I can say, IB equals to total voltage divided by their total resistances, and that will be equal to 330 plus 207.64, and that is 537.64. And if I divide this 537.64 from 50 voltage, sorry, I divide 50 volt by this 537.64, then I will get the current through this branch. 537.64. This is equal to 0.0929 ampere. Now, what can I do? 1, 2, 3, and it will be equal to 92.9 milliampere, and that will be the value IP. So, the current through this particular path B, is 92.9 milliampere, and this 92.9 milliampere will flow through R2 and will be divided in R3 and R4, and the target we have to achieve is to find current through R4. What we can do, we can simply apply CDR here, that current through R4, that is I4, will be equal to R3, as we studied in chapter number 6, current divider formula in two parallel resistances, that current of each branch is to be found. Leave that and write the other resistance in numerator, and denominator write their sum and multiply by total current entering in that parallel combination. Keep these words, total current entering this parallel combination, right? And here total current entering is 92.9, and R3 of the value 330, and their sum I have already calculated is 890 multiplied by 92.9. The last step is to find we have value current. I can apply this value 330 divided by 890, and this will be result in 0.0344, or if I write in milliampere, this will be 334.4 milliampere. Leave this. So 92.9 from 92.9 milliampere, the current through R4 will be 34.4 milliampere. And where will be the remaining current flow? The remaining current flow through R3. Very good. So far as we have discussed how to calculate total resistance in uh, series parallel combination circuit and how to find out total current in series parallel combination circuit. Then I discussed two examples to find out branch current in a series parallel combination. In next part of this week, inshallah, recorded lecture that I will share with you, we will be discussing voltage drops and further advanced topics. Till then, take care of yourself and keep studying. Allah Hafiz.